Our lesson today is about the mean and variance of a discrete random variable. And today's memory verse is found in Ecclesiastes 9, verse 10. It says, "Whatever you do, do well. For when you go to the grave, there will be no work or planning or knowledge or wisdom." If I'd like to paraphrase it, I could say it this way: whatever your hands find to do not settle for the average, but for excellence. In this lesson, we will be able to illustrate the mean and variance of a discrete random variable, and to calculate the mean and variance, to interpret its meaning, and also to solve problems involving mean and variance of probability distributions. I only have two examples for you today. And after that one, I need to merge both the mean, the variance, and the standard deviation computation so that you could have more time in answering your worksheet. Today's venture activity is about the mean or the average. Mean is a measure of central tendency, and it's also called as the average. Now, let's start with its definition. What is the mean of discrete random variable? Or what is the mean of the distribution? I mentioned a while ago that mean also means average, or it can also mean expected value. The mean is the weighted average of all possible values, or we can say the mean is the best measure of central tendency to represent the probability distribution. Like for example, if there are 30 students in a class, each of you has a different score, but your mean or the average best represents the class score. Now, how do we solve for the mean? 4 simple steps. Number 1, you construct the PMF. Number 2, you add a third column, the x times P of x. Number 3, you multiply columns 1 and 2, column for x and column for P of x. And the last is you need to add, or the summation of the third column is the mean of the probability distribution. Now, let me go directly to the steps in solving for the standard deviation and the variance. The variance tells about the spread. How scattered is your data? That is the variance. Now, how do we solve for the variance? We start with a table for the mean. What do? We add another column, that's x squared times P of x. Then we multiply the third column by the first column. You add, and then we subtract the sum from the square of the mean. And remember, the other is the standard deviation. It's still telling us how spread or dispersed the data is. And how to solve for standard deviation? It is simply the square root of the variance. Let's have 2 problems for today. And here's the first problem. We'll toss 2 coins. And as we check, remember when you toss 2 coins, remember our lesson last time, our x can be now. When we toss 2 coins and x is the number of heads, so our random variable x can be 0, 1, or 2. If you check in our previous lesson, P of x can be 1/4, 2/4, and 1/4. Now let me snip this table. I told you last time that I prefer not to simplify it. So 2/4 will stay as 2/4. That's for me to easily solve and add without a calculator. Now, let's start by solving for the mean. How do we solve for the mean? We dive with step 1, we constructed the PMF, and step 2 is adding another column. That's x times P of x. Based on the notation, it would mean that you need to multiply x and P of x in order to arrive to these column. So let's multiply. 0 times 1, that's 0. 1 times 2, that's 2 over 4. The last, 2 times 1, that's 2 over 4. Now, let's add this column. If we add this column, that's why I don't simplify it, so that I will simply add all the numerators. So 0 plus 2 plus 2, that's 4 over 4 or 1. Therefore, the mean, which is symbolized or represented by mu, is equal to 1. That's the answer. Now let's go to the variance. In the variance, from here you add another column. That's x squared P of x, probability of x. It would mean we square the x column, then you multiply by P. Or another way is the third column, you just have another x squared. You multiply by x. Any will do. You'll arrive at the same answer. Example, 0 squared is 0 times 1, that's still 0. 1 squared is 1 multiplied by 2, that's still 2/4. The last is 2. 2 squared, that's 4, times 1, that's 4 over 4. If you'll have the summation of this column, the answer will be 6 over 4, or that is 1.5. Now, how do we solve for the variance? Notation is sigma squared. Variance is mu squared minus the summation of the x squared times P of x column. Sorry, it's the other way around. It should be the summation of x squared P of x column minus mu squared. So we have 1.5 minus the square of 1. That's 1.5 minus 1. So our variance is 0.5. The last one, the standard deviation. For the standard deviation, it's the sigma is the square root of sigma squared. That is the square root of 0.5. This time for sure, you'll be using your calculators. And the square root of 0.5, let me check. The answer is 0.71. So we now have our three answers. We have our mean is 1, that's mu. Our sigma, we read this as sigma, the small letter for this one. Our sigma squared is 0.5, that's the variance. And our sigma, which is our standard deviation, is 0.71. Do you have any questions? If there's no other question, then we'll go to the next example. In our next example, we are talking about the grocery store. Let me snip it first. Here's the problem. The grocery items. The probability is that the customer will buy 1, 2, 3, 4, or 5 items in a grocery store are 310, 110, 110, 210, 2/10, and 3/10 respectively. What is the average number of items that a customer will buy? So we are asking about the mean of the discrete random variable. Wait for a while. Let me snip that first. Now here, we'll solve first the mean. So using this one, again, how to solve for the mean, we need to add another column. That's x times p of x. You multiply the two columns. Let's start. That's 3 over 10. The next is 2 over 10. Then 3 times 1, that's 3 over 10. 4 times 2, that's 8 over 10. 5 times 3, that's 15 over 10. So the summation of x times p of x column is 5, 8, 16, 31 over 10. Or we say our mean is 31 over 10, or that is 3.1. This is our first answer. Next, let's solve for the variance and the standard deviation. How to do it? Let's add another column. We call it the x squared times p of x column. So we now have 1 squared, that's 1 times 3, 3 over 10. 2 squared, that's 4 times 1, 4 over 10. Next, 3 squared is 9 times 1, 9 over 10. 4 squared is 16 times 2, that's 32 over 10. 5 squared is 25 times 3, that's 75 over 10. Now, let's have the summation. We just simply add it. Now, if we add all the numerators, we'll arrive to the answer, which is 123 over 10. Or we say our variance is 123 over 10, or that is 12.3. The last is our standard deviation, that's sigma. We simply find the square root of our variance. So that is the square root of 12.3. 12.3. Using your calculator, the square root of 12.3 is, that's not yet the answer. Sorry. Erase. Again, how to solve for the variance? It is the summation minus the square of the mean. So we now have 12.3 minus 3.1 squared. So our variance is 2.69. This is now our variance. And if we check, our standard deviation is the square root of 2.69. So our standard deviation is 1.64. So we now have our three answers. Again, the mean, which is 3.1, is the sum of these columns. Next, the standard deviation is solved as the summation of the fourth column subtracted by the square of the mean. And the last one, which is the standard deviation, is the square root of our variance.